Okay, now we proceed to the area under the curve or area between two curves, where you're gonna learn how to sketch the graph and evaluate the area under the curve using integration, and also area between two curves using integration. Okay, so basically, when you find the integration of the definite integral, right, you actually are looking for area under the curve, because the function that you got is actually a graph, and a graph, right, on a Cartesian plane. So when you draw the graph, and then you have the upper and lower limit, which when you integrate starting from A until B, you actually are looking for the area under the curve starting from the region A until B. So by right, if you see here, this red line is actually a function of fx, or the graph of fx. So when you have integral, when you have upper and lower limit, which is a to b, okay, this is actually the region that you want to find the area. So by right, what is the area of the function under the graph fx just now, starting from a to b? So you have to shape this until the x-axis. So that is the area under the curve. So I give you an example. Yeah, let's say if I have a curve, a straight line. Okay, this is x, this is y. Okay, I have straight line like this, a linear. And then I want to know the area under the graph starting from A to B, which is under the graph. By right, this is your graph. It should be under until the x-axis. So you shade here. In exam, you have to shade also. Okay, what is the area of the shaded part? What you have to do is just that you have to integrate the function fx here, okay, and then starting from A to B. So let's see if I have a quadratic function. Okay, let's say like this I have. Now I want to know the shaded region, which is starting from here to here, A to B. So the area under the curve, it should be starting from under your curve here, okay, up to x-axis. So let's say if I have another type of graph, which is, I give you like this. I want to know starting from A to B. So by right, area, the shaded part here is this one and this one. So how to find this? Using integration law. Okay, so let's say if I have this type of quadratic function, and I want to know starting from A to B, let's say. So the shaded part is here, because it should be under the curve, okay, until x-axis. Okay, so this is how you find the area under the curve law. Okay, now we proceed to answering the question. Okay, find the total area enclosed by the curve y equal to x minus x multiplied with x minus 1. Here you have to remember, in exam you have to draw. Sketching is the sketching give you marks. Okay, so you have to draw. No, here I think I made mistake. It shouldn't be this one. Remove. Okay, I have x multiplied with x minus 1. Now we have to find, when we want to find the area under the curve, okay, so by right we have to draw first, so that you know which is the region that is the part where we want to find the area. Have to draw so that you know. Okay, so we have to draw y equal to x multiply x minus 1, right? So you expand this guy, you're going to get x squared minus with x. So if you see, this is actually quadratic, right? Okay, so this is quadratic. Okay, our quadratic, it should be set or small graph. It depends on the value of a, or the coefficient of x squared, which is 1. So by right, our a is greater than 0, so it is a small graph. But then we don't know how many roots do we have here, so you have to use b squared minus 4ac. Okay, you use b squared minus 4ac. b is negative 1 square minus 4. Okay, we have a, which is 1, we have c, which is 0. The answer is 1. So by right, we have greater than 0, right? This one. So you have two different solutions, which is your graph should be like this. You have two roots, two value of x. So how to find the roots? To find the roots, you have to let y equal to 0. So you're going to get x minus 1 equal to 0. So x is equal to 0, x minus 1 equal to 0. So x equal to 1. So you have one is 0, another one is 1. So your roots is here, 0 and 1. Okay, you can start to draw. Just simply sketch. Okay, I just put here. Sorry. Yeah. Okay. So our graph is a smile graph. Okay. So it is 0 until 1. So let's say here is 0, and then you have to draw this. So 0 until 1. So where's the shaded part? Remember, it is under the graph, under the curve. Okay, until x-axis. So where is your x-axis? We want to know starting from 0 until 1, no? So it should be starting from here, this one, and then we have to shade it and bound it until x-axis, like this. So your shaded part is this one, no? And we want to know this. How to find this one? We can use integration. Okay, so because the function is actually equal to x multiplied with x minus 1. So here we can integrate, okay, y dx equal to a to b. So your y here is x squared minus x, because we expand already, dx, and then our a to b is 0 to 1. This is our a, this is our b. So 0 to 1. So here you integrate 1 by 1. X square, you copy, integrate, plus 1, divide with 3, minus with x is power 1, right? Plus 1, divide with 2. Then here you put the upper and lower limit, 0 and 1. And then you're going to get here, simplify first, you're going to get s to the power of 3 divide with 3, s square divide with 2, 0 to 1. Here you're going to get like this. So you substitute upper limit first. So 1 to the power of 3 divide with 3, minus with 1 to the power of 2 divide with 2. Minus with, you substitute lower limit inside. 0 to the power of 3 divided with 3, minus with 0 to the power of 2 divided with 2, which is you're going to get 0 over here. Okay. So 1 over 3 minus with 1 over 2, you're going to get negative 1 over 6, right? Okay, here, minus with 0. So you're going to get negative 1 over 6, which is, this is a negative value. Okay, the reason why you get negative, because your graph is actually under the x-axis, which is actually at the negative region. So that's why you get negative value. But then here, if you get like this, what you have to do is just put modulus in front. Then the value will change to 1 over 6 unit square. Like this only. So this is how you solve this type of question. And remember, you have to draw. Okay, so for this question you have to know how to draw. Okay, now we proceed to the next question. Okay, which is okay, sorry, we proceed to the next subtopic, which is area between two curves. Okay, so in your exam, this type of question will be in, which is they're going to ask you to solve the area between two curves. The one that we go through just now is actually area under a curve, only one function. Now when it comes to area between two curves, it's not only involved with one graph that you have to draw, you have to draw two, and then you have to find the area bounded between them. So if you imagine on this boundary means that, so the area bounded between them, you imagine like this. So yt, you have one function and you have another function, okay, and then these function are actually a different are drawn on your graph, and then you have to find the boundary of them. So you imagine that they are both are actually a fence, okay, both are fence, and then fence from, let's say, from top, and then from below, or top and bottom fence, and then you have to find the area between these two fence. So that is how we can find the area between two curves, the one that is bounded by each other. Okay, so for this one, remember this thing only, upper minus lower. So what you have to do is, when you have to solve area between two curves, okay, you take the function or the curve that is on the top one, or the top fence, you minus with the lower fence. Okay, and then you integrate as usual. Okay, now I give you visualization, yeah. Okay, so how to find the area, or to see where is the shaded area of two curve under a graph. So let's say we have a linear and quadratic. So let's say this is a linear graph, and I put it as y1. Then I have a quadratic like this, and I put this quadratic as y2. Now, where's the shaded part? Shaded part is actually the area that is bounded by these two curves. So when it is bounded by these two curves, which is, we have the area that is bounded is this part, this one, because here you have y1 and then here you have y2. Okay, and then when you want to find the area that is shaded here, right, okay, you have to find the area starting from the intersection point here, which I will put the starting as A, until the last intersection point, which is B. Okay, so how to find the area here using integration? Remember, upper minus lower. Okay, so we integrate upper minus lower starting from A to B, which is this interval lah. So from this one, we see our upper, how to choose upper and lower curve. The upper one you take, or you see from the shaded part, if you see, this is the upper one, and then you minus with the lower one, and then you minus with the lower one, which is this one. So the upper one is y1, okay, which is our linear, minus with y2. So this is how you find, and then you proceed lah, substitute the equation and all. Let's say we have another example. I include, I draw first. I have linear and then also quadratic. This is my y1, this is my y2. Okay, so where is the shaded part? Here, the area that bounded by these two curves, and the intersection point, the area is starting from A until B. So to find this, remember, upper minus lower. Okay, we integrate starting from A to B, integrate with respect of x. Where is upper? Check from the shaded part. The upper is this one, which is y1, minus with y2, which is the quadratic here. So when we integrate starting from A to B, which is the intersection point. Let's say I have another graph I draw here. I have maybe I just draw only random. I have graph like this. This one is my y2, this is my y1. So where is shaded part? Shaded part is here. Okay, and then the intersection point is here, A and B. So remember, upper minus lower dx. Okay, and then starting from A to B. So where is our upper? Right now our upper is this guy, the curve one. Okay, which is the quadratic, which is our y1. So it depends, it's not only y1 minus y2, it could be y2 minus y1. So you have to check from the graph, and then minus with y2, you check the upper and lower starting from A to B. So this is how you find or how you form the integration in order for you to find area between two curves. Okay, so we proceed to the example. Okay, we go to this question. Total area bounded by curve y equal to x to the power of 3 and y equal to x. Okay, so first step is we have to draw this, and then we have y equal to x to the power of 3 and then y equal to x. For y equal to x to the power of 3, the graph will be like this. because this is the basic graph for x to the power of 3. How to know? You have to know lah this one because you learn already this in your high school, or you can search first the basic shape for basic shape for x to the power of 3 graph, like that. Okay, and then y equal to x, the graph will look like this one. It's a linear function. Okay, like this. Okay, now we have to combine this both together. So you draw lah. You draw. Okay. So this is straight. I think I have to make it more curvy, like this. And then you have a straight line. So, straight line first maybe. Okay, now you draw like that. Okay, so here you have to find the shaded part, right? The shaded part should be this one, and also this. You have two right now, so we have to find here and here. So how to know this one? Because the upper and lower is totally different from these two region. Okay, if you check from here, okay, for the positive region of x, okay, so by right your upper is linear, so upper is x, lower is x to the power of 3. For this side, if you check, the upper is x to the power of 3, lower is x. So from here to here, from here to here, we have to follow this one. From here to here, we have to follow this one. Okay, because it's different position, okay. So now, when we want to calculate area, okay, the first step is, because it is at for this one, for this area, it is below x-axis, right? So by right, it is actually under the horizontal axis, which you're going to get negative value for the area. So you put modulus. If you don't want, also you can put later. Okay, here you integrate upper minus lower, which is x to the power of 3 minus with x. Okay, and then here you have to find the intersection, which is you have to find the interval a to b. How to find the interval a to b? This one and this one. So you have y equal to x to the power of 3, then you have y equal to x. You put them together, okay. By right, you're gonna get y equal to, okay, you find them, and then here you're gonna get equal to -1. This one you're gonna get equal to 1. Okay, so after that you substitute here, because at this region it is -1 until 0, right? So you put -1 until 0. Okay, and then you plus with x minus 3 for this region, this one, which is upper is x, lower is x to the power of 3. So you substitute here 0, 1, okay, and then this one still going to get positive because it is at the positive region. So you integrate them, so you're going to get x to the power of 4 divided with 4 minus with x squared divided with 2. Okay, integrate starting from -1 until 0, plus with, then you integrate x to the power of 2, you're going to divide with 2, and then you're going to get x to the power of 4 divided with 4, starting from 0 until 1. Okay, and then here you find the value inside. You're going to get 0 to the power of 4 divided with 4 minus 0 to the power of 2 divided with 2, minus with -1 to the power of 4 divided with 4 minus with -1 to the power of 2 divided with 2. Okay, plus with, here you have 1 to the power of 2 divided with 2 minus with 1 to the power of 4 divided with 4. Okay, minus with 0 to the power of 2 divided with 2 minus with 0 to the power of 4 divided with 4. So you calculate this until you're going to get the final answer. Here is equal to 1 over 4, modulus 1 over 4 plus with 1 over 4. So you'll get 2 over 4. So final answer is 1 over 2 unit square. Okay, so this is how you do for the total area bounded by the curve. But then I will show you in another video for the example question tutorial 4, 5 and 6. Okay, so for area under the curve, if you have any question, can ask me and the lecturer. Yeah? Okay, thank you and see you.